Hello students, in this video we will discuss the question from November 2020, paper 1, question 3. This is a question on discrete random variable under the topic probability. In order to attempt this question, you will need to know that the total probability is 1, and to calculate the expected value EX, you will need to sum up the product of X with its probability. The second formula is given in your formula sheet as SL 4.7. Let me show you on the screen right now. This one that is pointing to. Okay, let us start. A discrete random variable X has the following probability distribution. They've given us in a table, and we notice that in the table it involves unknown P and Q in different expressions. Part A, find an expression for Q in terms of P. We will be using total probability equals to 1 to do that. Part B, part 1, find the value of P which gives the largest value of EX. Now we will need to use our knowledge on how to do EX, write it out in terms of P, and then we will try to figure out what would be the largest value of EX and find that value of P that gives it. And using that part, we will have to find the largest value of EX. All right, part A. So as mentioned, we should use total probability equals to 1. And thus, let's write out these expressions and equate them to 1. So Q plus 4P squared plus P plus 0.7 minus 4P squared equals to 1. Let us simplify these. Let's put Q. There's only one Q available. And let's put the P's together. 4P squared and negative 4P squared, they will add up to 0. So we are left with P plus 0.7. Let's move them to the right-hand side. So 1 minus 0.7 minus P, and that will give us 0.3 minus P. And we have expressed Q in terms of P. So Q is 0.3 minus P. Part A is done. Right, we're done. Okay, for part B, part 1. Let us write down the expression for EX. We will need to pair up the X with the respective probability and add up these pairs of products. Okay, so 0 times Q plus 1 times P squared plus 2 times P plus 3 plus 0.7 minus 4P squared. Remember your brackets. And now let us simplify them. First term by term, and then finally we put like terms together. So 0 times Q is 0. We don't have to write that. 1 times 4P squared is 4P squared. 2P, 0.7 times 3 is 2.1. And 3 times negative 4P squared is negative 12P squared. Let's put the like terms together. 4P squared negative 12P squared, we get negative 8P squared plus 2P plus 2.1. All right. Now we want the largest value of EX, which means we want the largest possible value for this expression that represents EX. This is a quadratic expression. In order to find the largest value, one of the ways would be to do completing the square. Let's extract that expression. In order to do completing the square, you need to look at the coefficient of P squared and make it 1. So let's factorize this out. I'm going to just look at the front part, the terms involving P. And I'm going to leave 2.1 right at the end. So negative 8, I factor out, I have p squared. And in order to get 2, I need to multiply by negative 1/4 p. And I write down 2.1 at the end. Okay, now I work on the brackets, copying down negative 8 in the bracket, and I write down 2.1 at the end. We're going to work on completing the square. Let's write down p, and I have to half the coefficient of p. I'll get 1/8 squared, and I have to minus, subtract this value squared. Let me say that again. You need to halve the coefficient of p to get negative 1/8. All right. Let's go on. So we have negative 8 p minus 1/8 whole thing squared, and this part is 1/64. 2.1 stays on its own. Multiplying by negative 8. Negative 8 times negative 84 is positive 1/8 plus 2.1. We can then combine this. All right. .225. So in order for p to be maximum, this part that is a perfect square, this part has to be equals to 0. Let us write that down. Okay, for maximum EX, and EX is this expression, you need to subtract the least, which means you need to let this part be 0 without the square. And you can simply solve this and say that P is 1/8. Okay. Then it says, hence find the maximum EX value. That will be B part 2. This is B part 1. We go on to B part 2. Maximum EX, as we said, it will be when this part is 0. And we are done.